This is part 4, which is continued from the above examples, which is this is somewhat special example. The limit of sine x plus 3 over x squared plus 7x plus 12 as x approaches minus 3. If we substitute minus 3, if you substitute directly minus 3 as x approaches minus 3, it gives 0 over 0. But we cannot say 1 like the above examples, because the expression x minus 3 within sine x and the expression at the denominator x squared plus 7x plus 12 are different expressions, which violates the rule to say 1, because the expression here within sine x plus 3, but here is different. But if it was the same, we can say 1. But what will be the solution now? What challenges me on this? Then we will factorize the denominator, which means that the given limit, this one, then sine into x plus 3 over x squared plus 7x plus 12. When we factorize in terms of x plus 3, I have x plus 3 times into x plus 4. So I will be rearrange. I will separate this one into two limits, this using the limit property, then into this one. Then now it's okay. Now the limit for this one exactly 1, because x plus 3, and if you substitute minus 3, 0 over 0. So final answer is 1. The final answer is 1. Again, for this one, as x approaches minus 3, then minus 3 plus 4, which gives 1. Then 1 times 1 is the limit is 1. The limit is 1. This is the special example. So this special limit works. The first special limit works if the expression within the bracket in sine and the expression in the denominator are equal, and if we substitute into the approach value, it gives 0 over 0, or else in general it gives what you call the indeterminate values, which means that 0 over 0, infinity over infinity, or power 1 power of infinity, or infinity minus infinity, or infinity divided by infinity, or infinity times infinity. Such values are called indeterminate values. Okay, some additional examples based upon this special limit. For the first, still I'm dealing in the first special limit, which is limit of sine x over x as x approaches 0. As consequence of this one, we have seen a lot of examples. So I have here now these 3 examples we will answer based upon that fact. So what it says, the example 1, in order to the limit of sine into x minus 7 over x minus 7 is 1, to which value x approaches, a0, b1, c7, minus 7, d7. So the answer is just given the chance for you, but the answer is approaches x should be approaches to 7 in order to say the limit for this function is 1. You know why? If you substitute directly 7 into instead of x, this value gives This value gives 0 over 0. That's why the condition satisfies. So in order to delimit for this function is 1, then x should be approached to 7. The same thing, example 2. In order to evaluate the limits of sine into x plus 1 over x square minus 1 using the special limit, to which value should x approaches? To which value should approaches x 0, a 0, b minus 1, c 1, d 2. So you can test it. This one for individual. If you substitute 0, we can't. X. We cannot choose A, but because x cannot be approached to 0. You know why? If you substitute at instead of x 0 plus 1 sine 1, but the 0 square minus 1, which is equivalent to this one. We are going to search the value that makes for this one is 0 over 0. We are searching a value which makes for the expression if you substitute the number which gives 0 over 0. Okay, minus 1. Minus 1 plus 1 sine 0, then 0. That's okay. Minus 1 square, 1 minus 1, which is 0. Then this is the final answer. No, this one. B is the answer, but C is can't. We can't. Why? Because 1 plus 1 is 2 sine 2, which is not equivalent with 2. Or D, it is impossible. If you substitute, it does not satisfy. It does not satisfy 0. If you substitute 2, then sine 3 over 3, which is not equivalent to 0 over 0. So we can't select D. Then the correct answer is B. X should be approaches to minus 1. Example 3. What is the limit of sine x plus 1 over x cubic plus 6x squared plus 11x plus 6 as x approaches minus 1? A 1 over 2, B minus 1 over 2, C 3 over 2, D all. So then just take a time to calculate which one is the correct answer or the limit of for this function. Just apply. So apply the concept of special limits and evaluating whether it satisfies the two conditions. So let's go. Then solution. Just let's justify this one. If we substitute minus 1, or the value that x approaches, which is minus 1, directly it gives us 0 over 0. Okay, criteria 1 is satisfied. But we cannot say 1 like the above examples because the expression within the sign, which is x plus 1, and the expression at the denominator, x cubic plus 6x squared plus 11x plus 6 are different expressions, which it violates the rule to say 1. We cannot now. The answer is 1. Now, the first criteria, 0 over 0, is satisfied, but the expression within sine x and at the denominator are different. That's why we cannot say the answer or the limit is 1. So it needs further calculation. Then we will factorize the denominator as x minus 1. So you can factorize this one. This one is in long division. Or you can divide this expression by the denominator by this one, x plus 1. Use long division and divide, and you will have a quotient like this one, x plus 1 times x squared plus 5x plus 6. So using the property of the limit, so I have segregates into two limits. 1 sine x sine into x plus 1 over x plus 1, which is okay. If you substitute minus 1, it gives 0 over 0. Again, which satisfies the criteria. Again, we'll separate into 1 over x squared plus 5x plus 6 as x approaches minus 1. So in the first one, the limit is 1 since it's satisfied criteria. But for the second one, we will be substitute directly since this one is the polynomial. So every polynomial function is continuous at every number. So its limit is at minus 1. So I have substituted the minus 1 over the value of x. So it gives us finally then 1 times 1 over 2. Then 1 times 1 over 2. The final answer is 1 over 2. Final answer is. So our answer is A. Our answer is A. Another next to this one, this is linked with the other example or second example of special limits. Then limit 1 minus cos square x over x as x approaches x. Then A, it approaches to minus 1, and B, it approaches into 1, and C, it approaches into 0, D, it approaches to 2. So let's prove it using the solutions. 1 minus cos square x over x, the above will be factorized into 1 minus x plus 1 cos